Hello and welcome to the Maine Question podcast from the University of Maine. I'm your host, Ron Lisnett, and this is episode 2 of our 9th season and our second go-round in this new studio space we have. We're particularly excited for this episode, which has been in the works for a long time now. It's almost too much to cram into one episode, but we're going to give it a try. So, think about some of the most intractable problems in our world today. How to produce clean energy, find affordable housing, make the manufacturing process more sustainable and green, build longer-lasting roads and bridges, revive the forest products industry. All of these issues are overwhelming and extremely challenging on their own. Now imagine taking on these challenges simultaneously. That is the mission of the Advanced Structures and Composites Center at the University of Maine. It occupies an immense space on the east side of campus, and within those walls, state-of-the-art work is happening in all those areas and much more. As you walk through the space, there are projects, tests, and experiments happening in every corner. It's almost too much to take in at once. The ASCC, as it's known, has too many achievements and milestones to list for you here. More than 200 patents, 15 spin-off companies, 500 partners around the globe. But perhaps their biggest accomplishment is the 2,600 students who have worked at the ASCC. They've gone on to start their own companies, work in industry, and fill the vast need for engineers and other professions that Maine needs in order to grow the economy and prosper. And with that, we welcome in our guest today.
Habib Dagher came to UMaine in 1986 and became the founding director of the ASCC 10 years later. In the early days, much of the work combined composite materials with wood for smaller bridges and similar sized projects. From that humble beginning, the center has grown and evolved to take on some of the biggest, most pressing issues of our day.
Well, welcome. We appreciate you taking the time to talk to us. I know you're awfully busy, and we're really excited to talk to you. I mean, there's so many directions we could go, but maybe just tell us the evolution of all this. When I first got to the university, this was fall 1993, I was told I'm going to go shoot a project in North Byron, Maine with somebody named Habib Dagher. And you look the same as you did back then, by the way.
You're very kind. You haven't changed either. So.
Oh, thank you very much. But just talk about, fall 1993, we were doing composite bridges. What was your vision at the time, and how does it compare to what's going on now with the ASCC?
Thank you. Our goal has been all along is to add value to our largest natural resources in Maine. As you know, Maine is the most heavily forested state in the U.S., and adding value to the resource while we protect it and developing the leaders that would actually develop these technologies has been the mission from the beginning. So when we started working on composite or wood bridges, glulam bridges, was for the same reason, and that idea kind of grew to how do we look at more applications than just bridges. Yeah.
Right. So you grew up in Lebanon.
Yeah.
A long way away from a heavily forested area, certainly. Just talk about where you came from. How did you get interested in these topics? Why this direction as opposed to building a building or some other type of engineering?
Sure. Well, I came to the University of Maine as a faculty member 37 years ago. So that was a long time, and I'm hoping for 37 more.
Right.
This is a wonderful institution. My goal was to come into the structural engineering program and add value to the program and grow it. And living in Maine, you recognize right away that we are heavily forested. That's our biggest natural resource. And at the time, we were not really using it effectively. We had a lot of products, but we're also chipping logs. That we were shipping hemlock logs from a Portland seaport, completely raw logs. And once I asked somebody near the Portland seaport, what are these logs here, as high as you could see and as long as you could see? And the person says, I don't know, we're just shipping the log to overseas for someone to do something with them, make something with them, and sell it back to us. And that's really not what we need to do to protect our natural resources and add value to them. And that was the impetus to really do something different and figure out how to add value to these resources, protect them at the same time, and educate the leaders. So we put a proposal into the National Science Foundation. There was 4 of us at the time to create the center to add value to this resource. Fast forward to today, we've grown from the 4 people now to 411 people who work in the center.
Wow.
We're today the largest university-based research center in Maine. And we're still adding value to our natural resources. We're looking at wood and wood-based materials, but also the ocean. The ocean is the biggest other natural resource in Maine. So how do we add value to the wood and to the ocean is really what the center is looking to do. And we've put together a strategic plan in 2020. We call it GEM. And that stands for Green Energy and Materials. So our goal is to bring green energy and materials to society and to educate the leaders who will take these technologies and implement them in society. So.
You're exploring such a wide range of topics, everything from outer space to nanocellulose, to the smallest particle that you could possibly imagine. But the common theme, like you said, forestry and ocean, I mean, that weaves through no matter what project you're in. That's the basis.
That's correct. It's really how do we add value to these resources and protect them and educate the leaders that will develop these technologies. So we also have two very important values in addition to our GEM, if you wish, vision. And the values are students first. And our goal is to take students out of the classroom and put them in an environment where they can work together in teams. And we've had students from over 35 academic departments on campus come and work in the laboratory. Over 2,700 interns that get paid to work. The students can work up to 30 hours a week during the academic year and get paid to do that, and full-time in the summer and the breaks. So by the time an undergrad graduates from our lab, they've had over 2 years of full-time experience. And that is invaluable. They learn how to work together in teams. They learn how to appreciate each other and their others' disciplines, understand them. And that's how we're going to solve big problems, by working together across disciplines. So that's students first is one of our core, if you wish, values. And the other value is none of us is as smart as all of us. And it's really how do we all work together to solve the big problems that society is facing. And the big problems we're trying to solve right now, specific projects, are our energy system. How do we electrify our heating and transportation systems in the state of Maine? And the other big one is the housing crisis that we're faced with right now using additive manufacturing. So those are two of the big projects, if you wish, that we work on. So.
All right. I want to ask you about the students a little later in workforce development. We'll get to that. But there's been so many milestones and breakthroughs. We talked about some of them in the intro. More than 200 patents, 15 spin-off companies, partners around the globe, about 500 or so. What stands out to you about the accomplishments or milestones or anything that the ASCC has been able to do?
I think the most important piece is the 2,700 students that interned in our laboratory. And every one of those has at least one job offer on the way out. And it's really transforming their education is really what we're about here at this University of Maine. And of course, all the other things are exciting as well, particularly, we've just last summer, Governor Mills signed into law a bill to procure 3,000 megawatts of floating offshore wind technology. And had we not done the research for 15 years, that would not have happened.
Right.
And that's about a $8 to $10 billion construction project over 15 years in Maine that would transform the way we use energy in the state. So seeing that also happen and having the students be involved, if you wish, in that journey is very rewarding to all of us. And so, yeah.
So let's dig into some of the topic areas that we've been discussing. Might as well start with offshore wind.
Sure.
How do you describe to someone that knows nothing about this, though, or what it is or how it works or anything, what is the project, what is the potential, what is the opportunity?
Sure. As you know, in Maine, we spend more than $5 billion per year buying fossil fuels, heating oil and gasoline and so forth. That leaves the state as a whole. And when we burn that, of course, that doesn't do any good for the environment. So we embarked on a mission to figure out, are there natural resources in Maine that we could use to heat our homes and drive our cars? And what we found out 15 years ago, that within 50 miles of the coast of Maine, there's enough offshore wind capacity that's equivalent to 156 nuclear power plants, and just sitting out there. And so that is the largest untapped natural resource that Maine has had. So we're very energy rich. We're just not using that energy. So we've embarked on a mission to do that. The big technical challenge is we have very deep waters. So basically, you have to float the turbines in order to do that. So we've been researching ways to float turbines that could be fabricated in a port and towed out beyond the horizon that would bring energy back to the state of Maine. So think about a fixed bottom wind turbine that you see on shore. Take that and float it in the ocean, 30 miles or 40 miles offshore, and that's what we're designing and building.
So, and these are made from concrete, the base of these, right?
Yeah.
I mean, me with my 11th grade physics knowledge, concrete doesn't float.
Yeah.
But you guys have figured out a way to make that happen. That's the basis of what these turbines are sitting on?
Yes, the hull are made with floating concrete systems, and they float. The concrete floats because really we're using concrete cans. We call them flotation columns, essentially.
Okay.
Each hull has 3 concrete flotation columns, and it works like a catamaran, but we call it a trimaran. So if you sail the catamaran, it has 2 hulls, and the bigger the hull is, the more stable the cat is. The farther apart the hulls are, the more stable the catamaran is. So ours is a trimaran. It has 3 hulls, and each one of them is a concrete can. So if you make a wine barrel sized concrete can, they'll float too because it's got air in it. So what really makes it float is the air, not the concrete. So
right, 3,000 megawatts that's what you talked about is sort of the next big goal. How much energy is that? How much does it take to power the state of Maine, for example?
Yeah, that's very close to what it takes to power the state of Maine, but we're not going to use it to use it for turning the lights on at night, but we want to use that to really stop burning fossil fuels in our cars and stop using heating oil to heat our homes or natural gas. So basically, we're going to use that to electrify heating and transportation. So to use heat pumps driven by electricity to heat our homes, and many people know how heat pumps work. But now, if the electricity to run the heat pumps comes from offshore wind, it's like offshore wind heating your home. And then if electric cars, of course, are the future right now, and then if the offshore wind is filling up the car for us at night, then offshore wind is driving us up and down I-95. And that's where we're heading. We're heading to using this 3,000 megawatts to heat our home and drive our car and reduce our reliance on fossil fuels.
The next big topic area, housing.
Yes.
About a year ago, you printed the first biobased 3D printed home. Take us through that, and where's that headed?
Yeah, absolutely. So we printed what we call BioHome 3D. It's a 600 square foot 1-bedroom home that meets all the requirement of Maine state housing. The issue we're facing in Maine is, and in other parts of the country, is that we need a lot of homes and it costs too much right now. There's not too many people to build them. So in Maine, we don't have the labor to build the homes. Anybody trying to go even renovate a house or renovate a bathroom, they know they can't find people. So plus the cost of materials have skyrocketed. Plywood and OSB, if you go by and buy them, and 2x4s, they've grown so much because of the pandemic and the supply chain. So materials cost too much. We don't have enough people to build the home. So as a result of that, we have a crisis. So our idea was, working with the Maine State Housing Authority, is could we use wood waste, which we have lots of in Maine, to help print a home? Now, in wood waste is basically is the waste from the sawmills. We call that wood residuals. So when you saw a log, a lot of it doesn't make the grade. So that material used to be sent to the pulp and paper mills, but we had 5 pulp and paper mills in Maine shut down in 1 year. So that material now has to find a place to go. It's about a million tons of wood residuals in our sawmills in the region every year. Okay, that's enough to produce 100,000 homes. Now we're not going to, of course, use it all to print homes. So we're taking this wood waste, which is a crisis we have, and we're taking the housing crisis, which is another crisis we have, putting the two together and creating an opportunity. So, and that's what the vision here is. And by printing the home versus stick building the home, we deal with the labor crisis that we have. So if we can have machines and engineers producing the homes, and that's where BioHome 3D was born, is to do that. So we're partnered with the Maine State Housing right now and others in the state. So just in about 15 minutes, we're going to have the housing committee from the legislature will be in our lab to look at BioHome 3D for the first time. So,
wow.
Yeah.
So it's a win-win-win.
It is, and then so what we're trying to do is also develop an environmentally sustainable construction method. So we're printing with wood versus printing with concrete. Others are trying to print with concrete, and the difference in our technology is that we're printing the whole house, the roof, the floor, the walls. Whereas the concrete folks are only printing the walls, and they still stick build everything else. But in our technology, we're really printing everything, and we're prefabricating the home in a factory. That's the plan is, and take it in modules and then put it back together on site.
So almost everything in our society is built on petroleum products and plastics. It's in everything, as we know. How do you make that shift when it's baked into our way of life and jobs and everything out there? I mean, that's a challenge, I would imagine.
It is. It's a challenge, and that's the challenge that our GEM strategic plan really wants us to solve. Right. That's where we want to go. So in the housing components, I give you an example. This BioHome 3D that we printed has 30% less carbon footprint than a typical home when you build it during the construction process. It's 100% recyclable. So our children and grandchildren 200 years from now can take the house, grind it up, and put it back through the printer. We have a master's degree students right now doing that 5 times. So they're recycling the house 5 times to figure out how the material properties change. So think about if each time is 200 years of use, that's 1,000 years of reuse that we're looking at for these material systems. So we're thinking that way. We're developing technologies to allow us to do that. And everything it took to build this house was a naturally grown material. So as we grow more trees and sustainably, and that's the plan is, and develop bioresins that we're using, then everything we have is grown in a plant or in a tree of some sort, some form of plant or tree. So it's sustainable.
Problems go away like PFAS and other harmful chemicals and substances.
Yeah, certainly there's no PFAS in this, of course, this technology. And the other also that's a piece that's very important is reducing the waste. If you look at a stick-built home right now, there's a lot of truckloads that go to the dump just because you're cutting out the windows and the doors. In our case, you don't have to cut them out. We print the openings for the windows and the doors, exactly what we need, so we don't have to take and waste those materials. So our goal is to get to near zero waste during the fabrication and construction of the house.
Talk to us about you mentioned the GEM concept. I know there's a building in the works. What will be in that building? What's going to go on in there, and where is that project right now?
Yeah, GEM was another one of our moonshots in essence. This facility is called the Factory of the Future, a research factory of the future. It is to figure out how to scale up these manufacturing technologies for BioHome 3D and also for boat building. That we've printed a boat, as you know, 3 years ago. So how do we take these technologies and scale up the production processes? That's a lot of science and engineering that goes back through that. And so the goal of this facility is figure out how to scale up the production of BioHome 3D and the production of housing. So it's got 2 bays. One's a housing bay, one's is a boat building bay. And they're research bays. And students and faculty and staff are going to be able to work together to scale up those technologies. So we break ground this summer with this. And it's also we've formed a relationship with the new college, Maine College of Engineering and Computing, MCEC. So we're bringing engineering and computing together because this will be a smart factory using digital manufacturing, and as we're printing a home, for example, or fabricating a home or a boat, we're scanning that as we go along the way. And if everything is about to go wrong, something's going to go wrong, going to go off dimensions, is going to then we will know right away. Using the sensors, and using AI, we'll be able to go back and fix it before the problem really happens. That's where we're heading with a technology like this. We call it a closed-loop manufacturing process. And think about the students and the staff and the faculty in engineering and computing working together to try to solve some of these tough problems. Yeah.
And that gets to something that I've often thought about, in that Maine traditionally is always at the tail end of the pipeline. We have to import all the oil and gas we have. No way to generate our own energy, but this is a project, the offshore wind also, and manufacturing homes that relies on local resources that sort of turns that 180 degrees around. So Maine is now a generator and outputting and getting the economic benefit from all these ideas.
Absolutely, and if you look at, we talked about offshore wind, we spend $5+ billion per year. That's more than a state annual budget. in buying gasoline and fossil fuels in the state of Maine. If we can keep most of that here in Maine, and build this infrastructure and maintain it, the fuel's free. So that you're right. This is a direction we're heading. Plus, the impact on the environments are enormous in terms of benefits from not putting CO2 in the air, and the housing piece as well. Now, if we can grow everything we build our homes with and recycle it, here in Maine, we have natural resources to do that. So, and that gets back to the gem, which is green energy and materials. Right? These are the materials for the home are green. The energy is green, and that's really where we're heading. So.
And what's the timeline? When will this factory of the future be up and running, you hope?
We hope to break ground this August with the facility and to have it up and running 2 years later. So it takes about 2 years to get it up and running. So in 2026, we should have it up and running. We're also partnered already with with, for example, Panquist, which is a non-for-profit organization that focuses on housing in our area. And the first thing we'll do is print 9 homes for the homeless and prove that you could do that to help scale up the technology. So
one thing I've always been curious about, you're an engineer,
yeah.
So if I need to answer a calculus question or anything like that, I come to you. But so many of the projects and so many of the initiatives you're talking about involve politics, economics, sociology, psychology. How do you navigate through some of that? Did you ever think you were going to have to exercise that part of your brain as much as you've had to wade through some of the things to get where you want to go?
I think the key here is bringing people together. And as you know, the center, I tell everybody, is a non-denominational. In other words, anybody can come and work from across campus. So we've had over 35 different disciplines, like you said, economics, policy, business, engineering, communications. So we have people that have expertise in all the areas. The students and their staff and the faculty have come together to help solve these problems, and that's why working together is so important. So I learn every day. I learn from everyone that we work with, and we've learned how to work together. It took 27 years the center has started, and we've learned how to do that. We've learned how to work together across disciplines, and we keep learning every day.
Right. So, one other idea that I have so many here to get to, but roads, bridges.
Yeah.
I mean, that's another area you're working on. I know there's the bridge in a backpack.
Yeah.
Huge part of keeping an economy and a state going, right?
Yeah. Absolutely. Our roads and bridges are falling apart across the country, and in Maine as well, because of the corrosion of the steel that we have and on the road. So we have an initiative to have more durable bridges. And one of our next big projects is happening as we speak. It's the bridge coming into Orono after you take I-95 over the Stillwater River, and that's going to be close to a 500-foot long bridge designed using technology developed in our center. Wow. And it's going to be kind of a welcome to Orono, welcome to the University of Maine bridge that is designed to be corrosion free. So we instead of having to rebuild these bridges every 40 or 50 years, our goal is to see can we double and triple that. When you think about the Romans have aqueducts that they built 2,000 years ago that we're still using. You'd think we should be able to do it better than replacing our bridges every generation. So, the Maine DOT and other DOTs across the countries are on the same page. We've been working very closely with them. They're great partners. They understand that. And what's very interesting is that the older engineers who are leaving right now, the DOTs, saying, wait a minute, I'm replacing the bridge I designed 40 years ago. That's not right. So they're coming to us. Actually, the chief engineer from the Maine DOT joined a spin-off company that we had from the university, specifically so he can develop the next generation of materials that will last longer. So it's good to see that people are coming together to help solve some of these tough problems. Yeah.
So let's get back just real briefly to the students that you're putting out. Yeah. Workforce,
yes.
Filling labor needs. I mean, Maine is in desperate need, like a lot of places, for the next generation to come along. In some ways, that's maybe your greatest output or greatest product, right?
Absolutely. So as I've said, what I'm most proud of is we've had over 2,700 interns that have worked in this lab from 35 different academic departments. That's an army of people who are going out to the workforce and really taking these ideas and what they've learned in this lab and applying them in society. That's the best output that we have. And the factory of the future, the GEM factory of the future, research factory, is going to bring more of those students together from engineering, from computing together, to come and solve problems together. And that's the best thing we can give the students. Not only what they learn in the books, but what they learn by working together, what they learn by appreciating each other, by appreciating other people's disciplines and understanding, wow, I need an electrical engineer, I need a business student, I need a communication student, because that's the only way it's going to work. And they learn that at the university for 4 years. And that's the best ticket that we give them going into the workforce.
Final question. We always like to ask this, some version of this. Take us out 5, 10 years, or whatever time horizon you'd like. What are we going to see? What are we going to be amazed and surprised about out there, whether it's in the water or on land?
Certainly, being able to have floating turbines, at the end of the decade in the Gulf of Maine, producing electricity that could be used to heat our homes and drive our cars, is one of the biggest goals that we have going forward. So we're working very diligently to make that happen. So I would say floating turbines that we can go visit one day with a vessel and say, look what we've done. We're using our own energy, clean environment, all fabricated in Maine, is really what we'd like to be able to see. On the housing side, we'd like to be able to see more homes being produced here to help serve our society. There was a report last week that came out that the state of Maine needs nearly 80,000 housing units by 2030. 80,000. There's not enough people to build them all. So hopefully before the end of the decade, we'd have a factory here in Maine producing some of these homes using 3D printed biobased materials. I'd like to see that happen. So, yeah.
Great. Well, we could do an episode on all of these topics, and maybe we will down the road
Sure.
here as these things develop. But I want to thank you so much for taking the
Thank
time.
you.
We've
Thank you.
been wanting to talk to you a long time, and it's finally happened, so we're excited.
Thank you. It's a great pleasure to be with you. Thank you for all the work you do. Yeah, thanks.
Well, that's it for this episode. You can find the audio version of all of our podcasts on Apple and Google, Spotify, and SoundCloud, and the University of Maine website. If you have any questions or comments, please send them to Maine Question at maine.edu. We'll catch you next time on the Maine Question.